breaking all the rules. From Newton to Einstein, concepts elevate. Keep the stream, it's the key to our fate. Dr. Gold dropping gems, knowledge raining down. Actual education making scholars all around. Perpendicular minds, angles sharp as ice. Maths and physics, yeah, the future's real nice. Got the Pythagorean triangles about to flex. Quantum theories on deck, breaking all the specs. Relativity theories, worlds getting small. Grasp the universal laws, standing tall. From the atom to the cosmos, we rolling deep. Grazing up the stars, no time to sleep. Black holes and supernovas, concepts we unfold. Brain power heavy, yeah, that's Dr. Gold. Dr. Gold dropping gems, knowledge raining down. Actual education making scholars all around. Perpendicular minds, angles sharp as ice. Maths and physics, yeah, the future's real nice.
All right, what's up, everybody? Looks like things are behaving today. I'm so happy. My stream is working as planned. Wow. Well, let's see. I still have to go live on TikTok. We'll see what happens when we go live on TikTok. That might start messing some stuff up. Although I have my bitrate super low on that. I'll have that down to 2 kilobits. It should be okay. Boost my brightness though. I look kind of like not very bright.
Wow.
Wow. Right, Sensation? I think also your idea for us to go to 30 FPS was great because it has actually significantly improved things as well.
Just put it down to 2 just to make it extra junky.
No, I want my face to still look like kind of nice, right?
Well, you put it down to 2 and call it art.
Call it art. Yeah, well, it's called Art Deco, dude. It's Art Deco. Let me turn I'm trying to change my color so I don't look like I have fucking jaundice on TikTok.
I really like my whiskey.
Is that what happens? Do you get jaundice from whiskey? Is that really how this happens?
Jaundice, you turn yellow because your liver has stopped dealing with the toxins properly.
Oh, I didn't know that. Oh, okay.
It's
withdrawals.
It's more prevalent in someone's eyes. Your eyes go yellow as well. The whites of your eyes go yellow.
Yeah, I have heard also like you get like bloodshot eyes if like you're vaping too much and stuff. And then another one happens sometimes.
I would imagine that's true of any stimulant.
Yeah, stimulants are bad.
Oh no.
Well, stimulants are necessary for some people.
Oh, definitely. They were necessary for the Germans in World War II. I'll tell you that. I saw some interesting stats on like what was it, Operation Barbarossa? When, dude, do you know? I think I learned this at some point and then forgot because it was high school. But why did the Nazis turn on the Russians? That was like the dumbest tactical like idea ever. What? To fight a war on 2 fronts? Why did they do that?
They weren't thinking clearly. Let's start with that one.
Well, I mean, yeah, Hitler wasn't the most stable guy. Yeah, we understand that.
But the Nazi Party rose as a function of the communists.
Okay.
The TLDR is the communists were absolutely fucking destroying Germany, and then that's how the Nazis gained power in the first place.
Okay.
Wiped them out, and then went, there's a whole country full of communists.
It's like, what happened here?
So yeah, okay. it was never about the Jews to begin with. It was about these
about communists.
workers' parties.
I see. The labor unions and stuff.
It was a battle between all these workers' parties, because obviously the Nazi Party was the National Socialist, the National Socialist Workers' Party.
There's a W in there. Where did the W come from?
NAS. Well, it's in German, isn't it? So it's NASDP something.
Yeah, something. See, Kyle.
Yeah, let's stop talking about that. This is maths and physics.
This is maths and physics. Yeah, speaking of maths and physics. Oh, your hair looks good. Yeah, I'm losing my hair slowly. I had to proctor an exam today to like a lot of students. So here are all the students we had. Look at all. There's like 188 of them in this exam. Look at all these people. But one of the kids like came up to me and was saying like, that was so bad, that was so bad. And I'm like what? Like what's wrong? And then she handed in her exam, and look what she says. She wrote on the front here. She said, "Sorry about the crime scene." I'm like, "Sorry about the crime scene? What?" And then I just start noticing that there's blood on the exam. Oh no. There's a lot of blood on the exam.
I had a fucking nosebleed all over the exam.
Yeah, someone had a nosebleed during the exam. And because I guess this isn't my class, this is another professor. I was helping him proctor because he's in Paris. But apparently he has a very strict like no retake policy. So she was like, "Fuck it, I'm just gonna trek through this and take this exam." Right? I was just he's also like he's a Soviet, like, you know, Eastern Bloc type guy, real hard ass, I guess, to the kids, but
Russian police, stern but fair.
Stern but fair. What Equity says, so did the person have to retake their test? No, they took it and they just bled over half of it. They were so close to each other, couldn't they cheat? Yeah, definitely could cheat. Yeah, 100% could cheat. Yeah. I don't know. Some teachers do this thing where they give like multiple forms, like a Form A and Form B, and then they distribute it randomly. So if you're copying the person next to you, you're going to get the wrong thing because you have different questions. They don't pay me enough money to do that. Like, I don't care about like my whole philosophy is like, if you're going to cheat, cool, whatever. You're just fucking yourself for later. Because eventually, like, you have to like work a job. You have to do things. So if you cheat the whole time, like, you're eventually going to get fired. Yeah, I don't know. I think for the final exam, yeah, you have to prove your skill set at some point, right, Sensation? Yeah.
Yeah. So if you've learned nothing in 5 years, it'll be very apparent.
It'll be very apparent you didn't learn shit. Yeah, exactly.
It's like, you know, all these people saying, "Oh, I went through all this college and I go work as a barista in a coffee shop." It's like, yeah, that's why you're working as a barista in a coffee shop. Yeah,
it's because you were probably doing this, you know, soccer mom IQ math is what you were doing, you know.
You were a dumb cunt. You were a dumb cunt and you paid your way into university rather than, you know.
Rather than actually learning things. I agree. It happens, man, for sure. But it's all good. Actual Education shared the live video. What? I already am live, dude. How am I sharing my own live video? Whatever. But yeah, so probably for the final, I might put some effort into putting multiple forms, like a Form A, Form B, to kind of trick people up. But you know, it's a midterm. It's worth 10% of their grade. I don't really care, honestly. The final's worth 35. That I might take a little bit more precautions against cheating, but we'll see. Yeah. Anyways, good. Any other updates? Today's Earth Day. Apparently. Did you know that, Sensation? Today's Earth Day?
It rarely comes up.
So there was a funny thing. I was going through the UCLA Reddit, and someone was getting upset because, where is it? Yeah. They said, so UCLA, the official Instagram of UCLA, used AI to make their Earth Day post. Like, guys, come on.
Instead of wasting your time and money and effort into making dumb shit posters, go buy a can of soup for a homeless person. Yeah.
Well, that or, I mean, it's just hilarious because AI is, like, not very good for the environment. It's probably one of the worst things for the Earth. Yeah. It's just bad. And so, but they used AI to make their Earth Day photo. And I'm just like, come on, guys. What? Yeah, this is just like... This and, like... yeah, I don't know. There's a lot of... There's also, like, apparently, like... There's live sperm racing between our rival colleges. I don't know if Bob has seen this, but apparently this is a thing. And it's at, like, a massive, like, venue. I don't know, dude. There's some weird things going on in my college, I guess.
That's beyond weird.
Sensation's so confused.
It's usually this country that does all that kind of dumb shit.
I think so. I don't know, dude. We've lost it. We've lost our marbles. The 25th is Arbor Day. Arbor Day. Okay. That's the day for the trees, right? Arbor Day.
I don't know why that's a thing. It's only in the US as well.
You're right. Arbor Day is definitely a thing. But, yeah. Oh, I'm so happy. Sensation. Look, everything's working. All we had to do was switch to 30 FPS. You know? Now everything works. Good job, Sensation.
I'm still not entirely sure about the crux of the issue, but it's working, so let's not complain about something.
It'll break tomorrow, and then I'll be upset.
Yeah.
But yeah. So yeah, that's why I had to be. I was 30 minutes late streaming today because I had to deal with picking up all those exams and like, yeah, I guess some kid had a fucking nosebleed. I'm like, this is a biohazard now. Am I supposed to like run this through the scanner? Drop it to 15 FPS? No, because then you wouldn't see my hands. I like to teach with my hands a lot. You know, I need some fluidity to that, right?
24 is probably the floor.
Yeah, 24 is probably the floor before it starts looking weird.
24p.
24p. Wait, 24p would be like really low resolution. But the p is usually that's the vertical number of pixels. Like 1080p. It's 1080.
I'm sure because there's a difference, isn't it? There's P still stands for aggressive, I stands for interlaced.
Oh,
so
you're thinking about like 480i and 480p. Yeah, that has to do with interlaced.
I was thinking specifically about frame rate because I'm
really?
sure there's a difference. I'm sure there is like 24p as a frame rate.
Where's this 24i? Like interlaced?
It must exist, right?
Yeah.
I've seen it somewhere anyway.
What Sensation's talking about is like how they used to be able to try to save on the amount of data that they were sending because they were doing stuff over the airwaves, not over cables or satellites. Is they would only broadcast like half the lines on your screen, and then they would broadcast the next half, and then they would be so quick next to each other that your eye saw it as a single image. That's called interlaced, is what it is.
But it was very janky.
It's very janky, and also like if you had any sort of camera recording it, where the camera frame rate was higher than the eye frame rate, it could detect it. Yeah. Unless you took a picture and then you saw the big gap. Exactly. Yeah. If you took a still picture of it, you would notice that half your fucking screen was gone. You're like, what? Life is a lie. Okay. Anyways, yeah, that's all the news in my land today. I hope y'all's days is going well. We have some questions that got posted so far for the stream. If you're watching us from TikTok or YouTube, there's a whole link there, actualdiscord.com/submit. Go smash that link and you can go submit screenshots of questions for us to go over, which would be right here, actualdiscord.com/submit. You can just put your nice little username. Try to use the same username you have on whatever social media thing you're finding us on. And then you can upload a picture, and then we'll do it. We'll do it live on the stream. We'll do it live.
That's dope.
And seeing as I've got my captive audience again, don't forget to like the streams or whichever ones you're on.
Yes.
Share.
Like
just let people know we're here.
Yeah, we love that. We love to help you guys. Yeah. Outreach. Okay. Let's see. Is Adarsh in his house? Where's Adarsh? Adarsh does have a question. I saw he posted one. He posted one at 2 p.m. Or Shantrix, dude. Where's it? I haven't had a Shantrix question in a while, dude. Where's a Shantrix question? Where's like one of these hard ones that are supposed to make me cry? I could also do let's see. What's up, Seth? Seth, I haven't seen Seth in a while. What's up, Seth? It's crack-a-lackin' dog. Big G. Big Seth.
I'm quiet.
A little quiet. Oh, see, Rainy has some questions from before. I can. Let's go through some of these. These are some good ones. These are calc.
If he's here.
Yeah, it's okay. He's in Egypt, actually, Rainy. So I'll just answer his questions. Then I usually like just send them to him. He's in a. We're international. We have students from all over the world, which is really cool. Indeed. I mean, if you insist, why does air resistance vary with speed, but friction does not? Oh, interesting. Oh, yeah. Why is friction a Yeah, friction is dependent on the velocity, whereas air resistance is proportional to velocity, whereas friction is only dependent on the normal force. Yeah, friction doesn't matter how fast you're going across something. It only matters about the normal force. As to like why that is, yeah. What would you imagine?
In fundamental terms, I would imagine one's a force, and so it's a derivative of a real thing, so to speak. as opposed to air friction, which air resistance, which is a solid object. The faster you go, the more solid, the faster you go.
But there is a force, right? So air resistance is still a force. He brings up a good point here. So I mean, air resistance is still can be seen as a force, but usually what happens. So let's say something was moving in this direction with like a velocity. And let's say, for instance, you had like some turbojets, like we'd say like force of the thrust from the jets. So the jets are what like are making my jet go to the left. You would then also have an opposing force called force of air resistance. And this is what he's getting at is this is equal to B times V. It is proportional to the velocity. The faster you go, the more air resistance there is, okay? But then there's a cool thing here, which is called terminal velocity. Do you know about this sensation? Do you know, like, when you jump out of an airplane, that eventually you stop, like, accelerating downwards?
I never understood why, but I'm familiar with the concept.
Okay, I'll explain it. So, what's up, zombie? So if we have a person, right, and they're in, like, I don't know, an airplane. This is my very brutal attempt at what an airplane is. Yeah. And then they decide to, like, drop down. What's up, Seth? Is your mic working?
It's me.
Oh, it's Ethan. What's up, Ethan?
Hey, don't need to. Sorry, I deeply apologize for interrupting.
I deeply apologize. I don't mean to be a dick, but yeah, what's up?
Hey, what were you going to say just now?
What's up? What's up, dude? It's okay. What's up? What's up, dude?
But hey, I got some good news. Well,
what's your good news, dude?
You at least.
What's the good news? Tell me.
You remember how you saw my grades just yesterday, right?
I did.
Well, one of them got updated.
Nice. Which one was it? Was it literature?
It's math. No.
Oh, it's math. Oh, we like math. Math is a dope thing.
And you want to know what?
What is it? What's your score in math? How's it going?
It actually just went up to a 95.
95, nice, dude. That's an A plus. A plus. You got an A plus, dude.
That's an A. That's an A plus. Like
nice.
This teacher made us do this teacher made the entire class do like some work to make up for the lowest grade. I did like every question automatically.
And you did all of them?
Yes, of course.
Nice.
And possibly again, I might have the highest math average for this semester.
Oh, that's dope,
that's
dude.
True.
That's dope.
Well, the first place in my class for math, and I'll have an award just like I had last year.
Dude, hell yeah, dude. We love awards.
Seems like as if it's going well so far, but this is just one. There's still like 10 others left.
Well, you'll do well. Yeah, you just gotta keep trying, dude.
I cannot wait to see what happens. I hope physics has the same kind of results.
Okay.
But only next week I'll know.
Okay. Well, let us know, dude.
I'll pose a question later.
Please post a question. We have tons of time to go through questions, so please post them. So actually, Jeff, I think air resistance actually goes as the velocity squared. Hello there. Yeah, I can see all your chats there. Do you see them, Sensation? I see.
General Kenobi.
General Kenobi.
It's over, Anakin. I have the high ground.
Do you know Andor came out today? I really want to watch it. Or it comes out tonight, I think.
Wait, where did that line come from? It's over, Anakin. I have the high ground. Where did that come from?
Where did that come from?
Star Wars Episode 3.
Episode 3 on Mustafar.
Huh?
Mustafar.
Huh? Mustafar?
Mustafar. Mustafar is the planet where he does that. Yeah.
All right.
Fun fact: it's deemed to be one of the longest sword fights in movie history.
Is it? That's pretty cool.
Crazy.
I just need I don't need all the fancy equations. We're just like this. There's something where it's just like the easy surface area, because there's what's called like a drag coefficient. Yeah, this is so funny. Look at all this. This is kind of cool. Yeah, watch this. So like drag coefficient depends on like what your shape is. So if you're like a sphere traveling through, your drag coefficient is pretty high. If you're a cube, it's even higher. It's like the highest. But then if you're like a streamlined body, so this would be like an airplane wing, look how low it is, 0.04. I forget what a human is. I think a human is approximated as like a half sphere, maybe. Let me see. Human drag coefficient. Here we go. This is what I want to see. Oh, this is for like bikes. I want like, let me look at like skydiving maybe. High drag is you fall slower. Correct. Yeah, high drag means there's more air force resistance, keeping you up. I spelled coefficient wrong. Skydive. I just want someone to just give me the numbers for it. Here we go. Drag coefficient of a parachute. I guess you could do it for a parachutist.
Just reminded me of that one time that we got mashed up and ended up in Germany because we jumped out of a plane.
Ended up in Germany because we jumped out of a plane, he says. This is your
went to sleep.
Not your SAS days, right? Yeah, not the SAS days.
Not sleep. We went out on the piss and we ended up in Hull or something. That much I do remember. And then I woke up in Berlin.
Yeah.
With no passport, like a day later. And
oh Jesus.
We figured the only way we managed that is to jump out of a plane.
How did you get home? You just like call a cab? Like what?
I went to the consulate.
You went to the consulate. I love this. He's just like, we just jumped out of a plane and ended up in Germany.
It's the only way. I don't remember.
At least it's still the EU. You know? Or was it the EU at the time? It wasn't, or it wasn't? No, not really. EU was.
It was and it wasn't.
Yeah. Okay. So one sec. So, yeah, this is the key thing. So the force of air resistance, yeah, it actually goes as the velocity squared. And in this case, it's equal to BV squared, where B is a constant. This is a constant related to drag, which is basically, you know, how aerodynamic you are falling through the air, or in Sensation's case, not remembering to fall through the air. Tell me you at least got like some good food when you landed or something. Did you at least go to like the nearest, I don't know, strudel stand or something?
For days.
Oh yeah, okay. That makes, well, I mean, yeah. If you were under the influence to just jump out of a plane, I imagine so. Oh, so V squared is like the pressure against the fall. Yeah, you could kind of think of that, right? I'm trying to think how this works. Yeah, why is it proportional to V squared? Let's ask ChatGPT. I'm actually curious. Come on, ChatGPT, tell me. Why is air drag proportional to velocity squared? Here, let's turn on the super advanced one. O3. Yeah, go O3. Let's go. Ah, it has to do with Reynolds stress. Oh, that's cool. Each second they sweep out a tube of air whose mass is proportional to the air density rho, the cross-sectional area A, and the speed v. That air originally had zero momentum, and then after the collision, it deflected and leaves roughly the object speed. Therefore, the object loses momentum. Oh, okay. So this is a very important thing in physics. Yeah, force is equal to change in momentum over change in time, and I'll go into why that is. So, in physics, momentum, right? Momentum. P is equal to mv. So this is mass, and then this is velocity, okay? Now, if I look at the change in momentum and the change in time, so dp dt, okay? This is the same thing as ddt of mv. However, m, mass, is a constant, we hope. Hope your mass is not changing as things are happening. Otherwise, you're, like, falling apart. And that's called, like, the rocket equation.
Yourself on the way down.
Yeah. Yeah, if you do piss yourself on the way down, you would actually change mass. But mainly we look at this. So ddt of v. And so that's equal to m dv dt. But the change in velocity of the change in time is equal to acceleration. So what you get is that dp dt, the change in momentum over change in time, is equal to ma, which is the same thing as a force. Halo thing, yeah. What's up? What's up, Master Chief? What's up, Frozen Fusion?
Master Chef.
Yes. So yes. So this change in momentum is equal to a force. And so when we talk about air drag, the amount of momentum it's losing is equal to the mass of air that is being carved out, which is the density of air, rho, times the cross-sectional area, A, times the velocity. It's like it's the amount of, the speed at which you travel through air is like the amount of like height of like the chunk like you're taking out. Yeah, this is actually really cool. Yeah, I actually didn't know this, so I mean I appreciate you bringing this up. So
Kind of brings me back to what I said originally.
yeah.
Well, air is a very real thing, and the faster you travel through it, the more dense it becomes.
It is. Yeah, for sure, because it is like kind of like a pressure, I guess. Yeah. Because if you have let's just say a cross-sectional area here, and then you have some density of the air, right, which is rho. We know that density times volume, right, that's going to be equal to mass. And so if you do this times this, so density times the area, and then this would be, right, x, which is equal, so this x here, the amount of like height of the air that you're eating, that's equal to the velocity times the time. So it's how fast you're going times the amount of time that you're doing. So you could write out the mass here just as being rho a vt. This is the mass term. And then times velocity, right? Mass times velocity. And that's equal to momentum. And then if you just divide both sides by time, then you get dp dt, which is equal to a force, which is equal to rho a v squared. That's why it's v squared. That's really cool, actually. Oh, so his question was, why doesn't friction do the same thing? So, I mean, the technical definition is for friction, and I am going to teach this tomorrow during my class at UCLA. I have to teach friction. If you have an object, and all objects laying on the ground, or all objects on Earth have a force of gravity that's down, and they have a normal force that points up, this is usually equal to this. We can then say if something is moving, let's say there's like a pulling force this way, then there's a force of friction here, which is equal to, if it's moving, mu k Fn. So it only depends on the coefficient of friction between these two things and the normal force that's being applied. Why that is... Oh, definite intervals. That's cool, man, Frozen. Does that have to do with integration or something? Okay. But, yeah, so a good point. So basically we're asking, like, where does this formula come from? So let's see. So cool. I agree with this. This is all great. A dimensionless drag, typically 0.1 to 2 for blunt bodies. Okay. Blunt bodies just means, yeah, nothing crazy. So apparently it's not proportional to v squared when you start dealing with viscous fluids. So this is when fluids are like really thick. And then I guess when there's turbulence. There's a lot of stuff here. Okay. Yeah, it seems like the more length you have to push against, the more force switches against you. Yeah. Yeah, I agree with that. Okay. But okay, so I can say like, so why is the force of kinetic friction between two objects not dependent on the velocity? I actually imagine it would be dependent on the velocity kind of at some point, because then you would have heat. you would start having, if things are going fast enough, they start generating a lot of heat.
That's
okay.
Why you wear a flight suit.
That's where you wear a flight suit. Yeah. Did you wear a flight suit when you jumped out of your airplane in Germany? Sensation?
I don't remember. Again,
He still doesn't
I don't
remember.
actually remember jumping out of a plane. It's the only reason we can think of.
I have kind of a similar story where I was in college. I was pretty fucked up. I was at a party or something, and my friend who was in skydiving school or something, he was doing his jumps. You need like 30 jumps or something, right, to get trained. He had like kept wanting me to go skydiving, and I'm like deathly afraid of heights. But apparently that night, I just like threw my credit card at him and I said, "Book it, dude. Let's do it." I don't remember doing this. And then the next morning I woke up. I was hungover as anything. And he comes into my room at like 8 a.m. He's like, "You ready?" I'm like, "Ready for what?" He's like, "You booked skydiving last night." I was like, "Oh." I guess we got to do it. So
Let's do this.
Yeah, seriously, dude. That was the roughest flight on the way up. And then I jumped out of a plane. It was kind of dope. But I don't think I would have done it under like normal conditions. Yeah. Sometimes you need that little push. And sometimes it's Keystone Light. Okay.
Strange segue.
Yeah.
In the Power Rangers the movie, there was a skydiving scene.
Which movie?
But the Power Rangers the movie, 1995.
There's only one Power Rangers movie. I imagine there'd be a bunch of Power Rangers movies.
There's probably loads, but the original one.
Wait, wasn't that film originally just a bunch of random scenes shot in Japan, and then they turned it into like an English thing?
Okay,
like
so
it's all dubbed, right? Like Power Rangers is all dubbed. It's not actually.
Yeah.
It was never written actually for Power Rangers, but they just reused the footage.
The TV series was taken from a Japanese TV series called Super Sentai.
Okay.
Which have various other names added after the fact to distinguish which Super Sentai series it is. Anyway, yeah, that was true for the TV series, but the movie, interestingly enough, was done originally.
Oh, so they had like a plot, a cast, a script, and everything. They're like, "Yo, actually produce this."
Yeah.
I bet this is once it had like taken a little bit of popularity in the U.S. and they were like, "Oh, well, this is a cash cow. We should use this."
Yeah, I'm just trying to think how long it had been going on for. A couple of years by that point. So.
Yeah. That's why the Yellow Ranger doesn't have a squirt, but the pink one does. What's a squirt?
I don't know. Oh yeah, so in the American version, in the American version there were 2 female characters.
Yes.
But in the Super Sentai series that it was taken from, there was only 1 female character.
Ah. So they had
the Yellow Ranger in the original was a dude.
Oh, interesting. Oh, okay. I think he's meant skirt. Okay, a skirt. Okay, yeah. A little bit better there, Frozen. Yeah, you're good. Okay, but let's see. So for sliding, so for friction between like a solid and something else, and they're moving across. Yes. What happens is you have tiny solid welds. They call them apparently asperity junctions that form whenever 2 rough surfaces actually touch, and their strength is set by the material's hardness and chemistry, not by how fast you slide. So, yeah. In air drag, every second the body transfers momentum to a new parcel of air. So the faster you're doing that, the faster you're losing momentum. Kinetic friction, as soon as two dry surfaces touch, only a few microscopic peaks actually carry the load, and they flatten until the real contact area, A real, satisfies this. Okay. Okay, cool. So when you slide...
Is that sigma?
That is sigma, yeah, this is sigma. This is sigma right here. This is sigma. Can I get rid of this? Close the sidebar. Okay. And it's, so, and this is the formula I was showing you guys. So force of friction, kinetic, is mu kFn. And this is independent of any sort of velocity. Okay. That's pretty cool. Nice. Okay. So we learned something about friction today. And air resistance. So when friction exists, you're only barely touching the thing you're moving against. Correct. There are a bunch of like microscopic peaks that are, I guess, getting worn down as something like slides until the actual surface touches the other actual surface.
Yes, Reki, but you must say something constructive at some point.
What's up, Reki? Reki's just dropping emojis, dude.
Every time.
How this works, actually, this is actually cool. So you can do this with the parachute. So let's say, for instance, someone named Sensation jumped out of the airplane and did remember to deploy their parachute. Then what's going to happen is they're going to have the force of gravity pulling them down, but they're also going to have the force of the air resistance in the parachute pulling them up. And that's going to be equal to BV squared. Okay. Now, and this is what I'm going to teach in my class tomorrow, is that when you have a bunch of forces acting on an object, you can use what's called Newton's third law, which says that, or no, sorry, this is Newton's second law, that the sum of the forces, that's what this weird looking M is, this means the sum, or we'll say like F net, is equal to the mass times the acceleration of the object. Okay, so this is the acceleration. Now, when something is first thrown out of the plane, when Sensation first decides to put his foot out and jump out over Germany, he's initially going to have 0 velocity going down, right? So in that case, so when we say like, "What's up, Kevin Sauce? How you doing? How'd your test go?" So when you first jump out, V is equal to 0. 86, nice. We'll take it. It's a solid B+. You have the force of gravity, which is just equal to mg. And now there is no air resistance, because this is equal to B times V, which is equal to B times 0. So this goes away. So if you look at the sum of the forces on the person right as they step out, okay, you get the sum of the forces is just equal to negative mg. And sum of the forces equal to ma. So cancel, cancel. You get that G, or you get here that A is equal to negative G. And this should make sense. BV squared, thank you. So, but it's still 0. 0 squared is still 0. So, when you first jump out of the plane there, you are accelerating downwards at the acceleration due to gravity, which means you're moving down as fast as any other object would be if it were just dropped. Everything without air resistance falls down with a rate of acceleration, or a rate of the change in velocity, which is the acceleration of negative 9.8 meters per second squared. Yeah. I do tutor Calc 2. Ankit, if you want to submit a screenshot of one of your Calc 2 questions, I would be happy to go over it on the stream here. I'm just doing a quick physics question for someone, but if you submit something using our website down there, just take a picture of whatever your homework question is, and I can help you with it. Okay, so this is when you first jump out. Okay, but now we know, right, that acceleration is equal to the change in velocity over the change in time. So since this is negative 9.8, that means my velocity needs to start becoming more negative. And that makes sense, because as you fall down, you start, right, going faster and faster and faster. This is also what gives you like that pit in your stomach feeling of, I don't know if you've been on a roller coaster or maybe in a really fucking fast elevator, but if you ever notice like there are like butterflies in your stomach when you're like going up and down and stuff, it's the acceleration. It's your body's organs being like, yo, what? This is not real. This is not natural. It's not usual. And that's why you get that feeling. Okay. But let's say after jumping out. Okay. And let's just say after 1 second, for instance. We'll say after 1 second. So after 1 second, my velocity is equal to my initial velocity plus acceleration times time. So this would be V is equal to 0, and then it would be minus 9.8 times T. Okay? And then we've dropped for 1 second. I know people arguing with me will be like, oh, but the acceleration is constantly changing. Yeah, I know. But let's just approximate that it's just not changing for the first second, just to show a concept here. Now, my new velocity is equal to negative 9.8 meters per second. Okay? So if we draw a force diagram, we still have the same mg pulling down, right? Let's put this here. Right. Sorry, I need to move this. I want to move it. There we go. Okay. We still have the same force of gravity pulling down. But now there's a drag force upwards, okay? And this is equal to B times V squared, which we assumed for the parachute, that's 50. B is equal to 50, okay? So this would be equal to 50 times negative 9.8 squared. And this is where we need to come up with a mass. You do need mass for this now in order to do this. So let's say, I don't know.
100 kilograms.
Yeah, 100 kilograms sounds good, right? Yeah, 220, little beefy boy. Yeah, nice. Okay, 100 kilograms. Yeah. How do we determine that the force is bv squared experimentally? Is there some intuition why it's v squared and not some other power of v? Yes. So we went over that earlier, C-bomb, but I'll show you real quick. It has to do with this. So momentum, right? This is p, which is mass times velocity, okay? Which means that the change in momentum over the change in time would be mass times acceleration, okay? Which that is a force. So in order to get the drag force, I'm going to look at how much the momentum is changing of something as it is going through the air. And what we talk about is that if, for instance, this were like a tube of air that you're having to move out of the way, which means you're having to take your momentum, exert it on the air, and then the air gets out of the way so that you can keep moving. The amount of momentum in this pocket of air that you had would be equal to the density of the air, so that's rho, times the cross-sectional area, A, times the height of this column of air you took out, and that's x. And x, right, would be proportional to your velocity times the time. So velocity is like how fast you're running through, right, the air, and then time is how long you've run through the air. So if we think of like density times volume equal to mass, this is density, this is volume, this whole thing becomes mass, and then you have mass times velocity is momentum. Now what I do is I divide both sides by t to get like delta momentum, delta time. And that's what gets me rho AV times V, and that gets you rho AV squared. And delta momentum, delta time, dp dt, that's equal to a force. So the assumptions you're making from what I read was that you have a low Reynolds number. There's not turbulence. Like it's you know, like regular fluid flow, basically. If you have other weird stuff going on, then like things kind of get messed up. But yeah. Oh, sorry, Kevin. Yeah, I didn't see that. Yeah. Yeah, for sure. So, anyways.
So many chats, so little time.
I know. That's why I have them all on like one big prompter screen here, so I can like see everything. Although, yeah, the only one I haven't gotten to fit into it is Discord. Discord I have to run on a separate thing because they don't have a plugin for it yet. It's super annoying. Ugh.
APIs.
Okay, sorry. Okay, 100 kilos times 9.8. Okay, that's the force of gravity pulling down. So now let's look at what like our F net is. So F net is now going to be equal to this minus this. So that's 50 times 9.8, or negative 9.8 technically squared, minus 100 times 9.8. And then we need a calculator for this. Where's my calculator? Dun, 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 dun. There you go. Okay, so if I pull my calculator up, and we do 50 times 9.8 squared, cool. And then I minus that by 100 times 9.8, which is 980. Cool, that gets me 3822. Okay, so now my net force is 3822. Wait, this should be bigger than this. Otherwise, we're gonna have like positive acceleration. Dun, dun, dun. Is it really 50? The parachute is 50. Okay. They put 80 kilos. Yeah, V naught 10. Okay. Yeah, this should all be working. One sec. Oh, that makes sense. The acceleration is going to be upwards. Yeah, because velocity's changing from negative to positive. Yeah, duh. Okay. So, yeah, this is 3822. Yeah, because that's 10 squared, it's 100. 100 times 50 is 5,000. Yeah. Minus. That's a big coefficient, I guess, for that. Okay, whatever. Okay. This is F net. And then this is equal to the mass, right, which was 100 kilos times the acceleration. So you divide that by 100, divide by 100, and then you're going to get 38.22 equals A. Wow, that's a really big positive acceleration. So yeah. So now your net force is pointing up. And so you're no longer accelerating downwards. When you jumped out, you had a negative acceleration because your velocity was getting more negative. Now your velocity is going to start going up from a negative value to basically 0. What we really want to figure out is what's called terminal velocity. So terminal velocity is when acceleration is equal to 0. Okay, that means when you're no longer going more down. Also, you can't technically be going up. So terminal velocity happens when your drag force is equal to your force of gravity. When these are equal. So when F drag equals F gravity. So what we saw here is that F drag was BV squared. So that's equal to 50 V squared. And then the force of gravity was 100 times negative 9.8. Okay. So, if we do that in our calculator, 100, so that's going to be negative 980. Well, you make these positive because you can't take the square root of negative numbers. Whatever. 980 over 50 is equal to V squared. And then we take the square root of that. And then we get that V is... Okay, so this is why my equation didn't work out too well. V is equal to... Because the second he deploys the parachute, he will instantly stop going down at negative 9.8 meters per second. This is actually... Okay, this is why this answer we got here is like kind of nonsensical. Because I was like, wait, acceleration can't be... You can't be like moving upwards. Like what? It has to do with this. So this is the fastest that you can fall out of the sky with a parachute. It's only 4.4 meters per second. Because if you go any faster, then the drag force starts beating out gravity. And that won't make any sense because you're falling down. You can't start like going back up. So, yeah. And then what is that in miles per hour? That's a good question, actually. Yeah, it's only 10 miles an hour. Wow. Okay. So yeah, it turns out those parachutes only let you drop at 10 miles an hour. Yeah. Maybe you've noticed that?
Now remember, you can indeed jump out of a plane without a parachute. Once.
Yes, you only get to do it once. I think some people have survived jumping out of airplanes though.
Yeah, we were taught about that. In case of
you hit
parachute
the trees,
failure, never
right? You
don't
hit the
aim
trees.
for the water.
Oh, don't aim for the water. What do you aim for? The trees, right?
You aim for the ground.
Oh, why not the water? Because like you'll knock out and then drown.
It becomes a solid mass.
Oh, at high speeds. Yeah, it's like hitting concrete.
Yeah, and so what you do is once you reach 100 feet or something, you just spread yourself out as far as you can, and then tuck and roll and land on your back.
Let's see what the highest survival fall is. Okay. The highest documented survival of a fall without a parachute was 33,000 feet. 33,330 feet. It was achieved by Vesna Volovich, a flight attendant, in 1972 after a bomb detonated on her airline's flight. She survived by being trapped in a section of the aircraft's fuselage that landed on a heavily wooded and snowy mountainside. Oh. Dude, imagine being that. Wow. What did she survive though? I guess she had to survive, right? So there was a bomb. The plane exploded in 3 pieces. She was thrown out of the aircraft. She survived by being trapped in a section of the fuselage which landed at an angle on a snowy mountainside. She suffered a fractured skull, 3 broken vertebrae, broken legs, broken ribs, and a fractured pelvis. Despite her injuries, she made a full recovery, and she is now the national hero of Yugoslavia.
Yugoslavia doesn't exist anymore, does it?
It's Serbia now, I guess, right? Damn, look at this person, badass, dude. What? She like fell out of an airplane. She's still alive? That's super dope. Oh, she was in a coma though for several months.
Yeah.
She was temporarily paralyzed.
Put you into a coma.
Yeah. She had no fear of flying afterwards. This is the epitome of like just fucking harsh Eastern European like willpower. Despite her willingness to return to work as a flight attendant, they gave her a desk job. Bro, can you imagine, dog? You fall out of a fucking plane and you're like, yo, put me back. I want to go back to serving drinks and crackers. What? That's nuts. Oh, it's too funny, but unfortunately, she was fired in the 1990s after taking part in anti-government protests. Yes. Oh, and she was a pro-democracy person. Wow. She struggled with survivor guilt. Oh, okay. Anyways, yeah, I guess it's possible. So people have survived out of airplanes before. That's fucking crazy, man. What's up, Aduki?
Question time.
Yeah, question time. Let's see. We got any more questions? Well, I had this one I wanted to do. Where is it? Oh, and then let me make sure, because TikTok will start getting upset at me in like an hour. I have a solution for this sensation. I'm getting another monitor, but
Okay.
it's like a small portable monitor. You know, like one of those little ones that you can like, I don't know. And I'm gonna use that just to project the TikTok so I can see when it's gonna ask for the funny captcha. Anyways, let's see. This is a good one. Check calculator off. Okay. Choose a correct answer from the given ones. Oh, this is just, well, tangent's easy. We should do this one. This one's actually pretty good. Dun, 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 dun. Okay. If cosecant of x, if y equals cosecant of 2x, then what's dy dx at x equals pi over 6? Interesting. Well, for this one, you have to know what derivatives are, I guess, right? So, if y is equal to cosecant of 2x, what is dy dx? Okay. This is
nice.
What's not nice about it, besides it being a, it's a, was it chain rule, right?
Each head. I don't know. I do have two things we can do today if we only think better.
What's up? What do you have? What do you have things? What do you have things, Seth?
I will wait on them if we don't have anything better.
Okay, let me finish this one and then we can, because I don't think we have any other questions yet.
Cosecant of u du. Write this down.
Yeah.
Cosecant of u du.
Yeah.
Equals negative natural log of the absolute value of cosecant u plus cotangent u in that you have to plus
And
c.
then plus C. Yeah, this is if I had to integrate it, right? This would suck. I really don't want to integrate this, right?
Absolutely not.
No, but this one we're just taking the derivative of, Seth, right? So
yes, if that's what it says to do, then yeah.
yeah. So if I do ddx of cosecant of what I say is like box, right? Is that negative cosecant cotangent?
And there's the form. Negative natural lot of stuff.
Well, no. This is. I think this is like the integral of this is equal to this.
Nope, nope. I'm looking at iteration. Wrong thing. On me.
Wait, 1 sec.
Here's the right one. Do it.
Oh.
At it. I have it.
Law Bean says, is this AP Calculus AB review? It could be, if you want it
It's
to be.
just negative of the, it's just the negative of the middle of that middle expression.
Yeah, 1
And
second.
then right. Section.
No, yeah. Look, the derivative of cosecant
know.
is negative cosecant
I
cotangent.
just repeated myself. I just repeated the statement.
Oh,
The
okay.
derivative of cosecant is negative cosecant. That's not it. That's a repeating cosecant, which means it's not it.
It's this one. No, it is. Because the derivative of secant is secant tan. I remember that.
The derivative of cosecant is not can't.
It's negative cosecant cotangent. So this is negative cosecant
A
box.
Negative cotangent.
cotangent of box. Yeah, exactly.
And
But then we need the
and then
derivative of
negative
what's inside here, right? So then it's
So-
times ddx of, I say, like the box.
then
I love the box. Oh, look, I have to. Well, 1 sec. I have to do a TikTok thing. Okay, which of these objects are used in touchdowns? Bro, these questions are hilarious, dude. Yeah, footballs. It's like footballs. I want to say hard drives and hats. Verification complete. Okay, we did it. It was right around the 1 hour mark. Okay, so this is going to be negative cosecant of, and then the box thing is now, right? We're gonna say this is like 2x. So this is 2x cotangent.
We have to leave it that way. You know why?
Why?
I'm gonna use the adds value that we have and just and just find the
Yeah,
value
and
of
just
the
plug it in. Yeah, you're right.
Of
We could do
course.
that.
We know the value of the box.
But we have to do
I was three.
ddx of the box, which is then
Well,
equal
that
to.
of two
That's equal to
axes
2. This
is
is equal to
dealt
2.
with.
Correct.
And
yeah,
2x is
nice.
pi over is pi over 3. So
I think it's just 2 though, for this. But you're right. So for this one, right? Yeah,
Times
2x
stuff.
is equal to 2 times pi. Is it pi over 6? Yeah, pi over 6.
Yes.
Which is equal to pi over 3. Okay.
Pi over 3. Yep. 2 pi over
So-
6, which is pi over
So
3.
negative cosecant of pi over 3, cotangent of pi over 3.
And then remember, move your negative over a little bit and bring your 2 in front of that.
I agree. He says, let's
There's
put this over here.
negative times-
Let's put this way over here.
Negative 1s.
Here you go. Come here.
There's
Come
that
here.
2 in
Come here.
place.
There we go. Okay.
Because that is values, which
Now cosecant and cotangent of pi over 3. This is where,
Okay,
you know,
I'm
people.
gonna do something. I'm gonna do a simple thing before we do the value finding.
What do you want to
We
do?
can find it a little bit easier, maybe.
You want to turn this into sine and cosine?
Not
Yeah,
no,
I
not
agree with
sine
that.
and cosine, into
No.
their nicer versions.
Okay. What's a nicer version of
So-
cosecant? Is it 1 over sine?
Yep. Yeah. One
Yeah.
one over the with C's do not go together.
Yeah. So cosecant is 1 over sine,
C's do not go together.
and then
Thing. And then
and then
cotangent is tangent.
cotangent is
That
cosine
would
over
be
sine.
good. Nope,
Yeah.
we don't want that. I just wanted 1 over sine, 1 over tangent, because we know tangent.
Oh, okay. Yeah, we can do that too.
I know I
That's
have
fine.
unit circle handy. I know tangents. I don't care about. I don't know.
I
cosecants.
always tell people not to use the unit circle.
I was doing that to make.
Yeah. The way I like to do it, and I'll just show it because this is always like a good little
Yeah,
handy
do that.
tip for
I'm
people.
gonna say that we can do it that way too. Either one. I'm
Yeah.
gonna give the value either way, but I'm saying.
I just
have
always
it
like
here.
it. Pi over
So-
3 is what? Is that 60 degrees, Seth? Pi over 3, 60 degrees.
Oh. And then I remember right here I have the sheet.
So if this is 60 degrees, right?
60, 30, 90. Yeah.
And then this is always 1. I always say the hypotenuse is always 1. Some people get upset and they do the 1, 2 square root of 3 thing, but I don't like doing that one. I'm like, nah, none of that. I like having the hypotenuse 1. Then I say like this is the opposite. And then this right here is going to be the adjacent. Or let me make a different color for this one. Let's use green. Yeah. This is the adjacent. And then in a 30, 60, 90, this is 30 degrees. Then this is 1/2, and then this side is square root of 3 over 2.
And then they're giving you.
Right. And then, so we wanted -2, 1 over sine and then 1 over cosine, and then it's of the pi over 3. Sorry, I forgot about this. Sorry, no, I fucked up. Sorry, 1 over sine of pi over 3, and then 1 over tangent of pi over 3.
Yes.
Okay. Sine of pi over 3 is opposite over hypotenuse. So this is going to be -2, 1 over the square root of 3 over 2 over 1. So it's just
There's
the
the
same
flip.
thing.
Yeah. And there's the flip.
There's
Yeah.
the flip. And then tangent is opposite over adjacent. So that's going to be square root of 3 over 2 over 1 over 2. Right?
Fraction by.
And then I like to just cancel the
Denominators
2's here.
If the denominators of 2 fractions A and B are the same, then the denominators are no longer there.
Good. Yeah. So this is gonna
And
come
ones can
up.
cancel. Ones can
So-
cancel.
The ones can cancel. Sorry.
Ones can cancel because the denominators are the same.
Oh,
Whatever
yeah,
one
for
is
sure,
sort
for
of-
sure. Yeah, oh, I see what you're saying. Yeah. I don't need this. I don't
Those
need this.
cancel each other.
Correct. You're right. I don't know this.
No, not of each other. Of the fraction as itself. I'm talking about the fraction.
Oh, you talking about this one and this one?
That and the other one. It has the same rule.
Oh, okay.
One can be written as 1 over 1.
Correct.
Now, technically, the numerators do not cancel because they're 1 over 1.
Well, yeah, and this one's gonna be when we bring it up to the top. That's gonna be 2 over square root of 3, and then this is gonna be times 1 over the square root of 3, right?
And no need to worry about having to deal with
Oh,
that.
nice. I don't have to rationalize as a denominator. That's dope.
That's dope.
I'm so happy about that. I don't have to rationalize denominators. Okay, because square root of 3 times square root of 3 is just 3.
Reason why? There's actually a simple reason why.
What's this? What is the simple reason why?
Multiply those together in terms of sine and cosine for me. And you'll see it. Cosecant times cotangent.
Oh, cosecant times cotangent. So that's 1 over
Multiply in
sine.
terms of sine and cosine.
Oh,
You'll
I
see
know what you're talking about because it's cosine over sine.
Is it
So I'm gonna
the-
get
oh,
cosine
wait,
over
no.
sine squared.
Wait, at cosine over sine, or is it a?
Yeah, cosine. It's cosine over sine squared, right?
What? Yep. And then you'll have and then you notice now. And what does sine
Nice.
squared do with when you square root of the y?
Yeah. So then that answer was, dude. He marked this one off. He said it wasn't B. It is B, bro. What? Excuse me. It is B. Dude, what?
CLI is a nice easy one.
Yeah. Ankit in the TikTok is saying, "Can I do 24 times 6 in my head?" I can. That's 144, right? Is that 144?
4 by 12.
If you want to know how I did that, yeah. So actually, Seth has probably some cool trick. I'll show you my trick, and then I think Seth has an even better one. I would say that 6 times 24 is the same thing as 6 times 20 plus
That's what I
6
do-
times
that's what I do
4.
with larger numbers.
Right, and this is 120, and then this is 24, and then
That's
you
my rule
add
of
them, and
larger
you get
numbers.
144.
But if they're nice like that,
Yeah, why is this one nice? This one's really nice, right? Because what can we write 24 as? We can write it as 2 times 12, right? Yeah, so I can write this as 2 times 12, right? So now I have 6 times 2 times 12. 6 times 2 is 12, and 12 times 12, right, that's 12 squared, and that's equal to 144. So that's another trick you can do to solve it quickly, I would say.
it's easy.
Yeah. Damn, I'm crazy
So, yeah,
smart? No, it's
so-
just algebra tricks.
Yeah, and also when they marked it like that, that actually means that's their answer. That's the way they mark answers.
Oh, you think that's how they mark answers on this one? Oh.
Yep, I've done that before. It's neat. C's an easy one. Number 3 there is an easy one.
Yeah. Yeah, why is it easy? Because, yeah.
Cosine
It's
squared x plus sine squared x is 1.
yeah, it's just 1.
Derivative
that?
of 1 is 0.
Yeah, this is a funny one.
And the top one's a function Watson.
Yeah, we can do that one. And then Ethan posted one. We'll do one of Ethan's
Yeah,
questions.
I know
So
we
yeah.
have no Adarsh up.
Oh, is Adarshan in the chat? I mean,
Okay.
I was waiting
Yeah,
for him to
there.
show up.
He came in and he said it.
Oh, okay, cool. Okay,
Darsh is
cosine
on
squared plus
bad
sine squared is the same thing as 1. This is an important thing to know. If you add these up, it's 1. And so, what's up, Adarsh? I see you, dude. All right, so, and ddx of 1, if you take the derivative of a constant, that just gets you 0.
0.
Easy. Easy, GG.
And the other's a function function.
Uh-huh.
Find the function value. The other one says find a function value.
Yes, was it tangent of 5 times pi over 4
Over 4
minus pi?
Yeah.
So that's 5/4 pi.
Yeah.
I can do yours
So what?
next. minus 4/4 pi, right?
Yep.
And so that's 1/4 pi.
Tangent of 1/4 pi. Tangent of 90 degrees.
Pi, yeah, or 45.
Pi over 4. Nope. What do you got?
Yeah, pi over 4 is 45 degrees. Yeah, and that's an easy one. I always tell people with that. So, again, you can kind of think about the circle. So pi over 4 is the same thing as 45 degrees. And if you have, it is 1. It is, Isaac. You're so right. It is 1. Because if this is 45 degrees, okay, and then this is 1, then the other part of your triangle here has to also be 45 degrees. And this is 90. And so whatever this side is, this side will be the same. And this is called like an isosceles triangle. That's what it is. Because same angle, same side. Or we say like side length of a triangle is proportional to what the angle is. Yup. Okay.
Darsh is kind of an easy one, and I'm happy it's written in that way.
All right. Yeah, let's pull it Darsh's in.
I'm happy it's written in that way because reading that almost differently than
Forget
that's
it.
notation.
Teaching someone later. One second. Let me make sure. Oh, I am. Okay. In 24 minutes, I have to go teach someone
Oh, you have to do
Diffie Q. No, I have to go teach them vector calc.
Are we ready for mine
You want
now?
to be
We're gonna do a
Genetic
Darsh's real
case.
quick, and then Ethan, I'll have time for you for yours for sure.
Ethan's
Okay.
quit.
Ethan's here. So given f of x is 2x squared minus 8, g of x is equal to that,
What
and
part are you doing?
h
We
of
don't
x
know
is... Oh, sorry, I need to show my screen. Sorry, my bad. Find each function. Okay. Yeah, okay.
that. 5 is the one we care about.
All right. I believe this is this composite function?
That's multiplication by what it looks like, but
Oh, is it f of x times g of x?
it's.
I always
it's
get
not- where's
confused-
G of X coming from in this?
I always get sorry, not g, sorry, h. I always get confused about this. So I think this, for instance, is equal to
Isaac,
f of
f of
h of
x.
x, right?
That's what I'm wondering. Is this supposed to say F times?
But is this equal to f of x times h of x?
What is it telling you?
Isaac seems to think that it's f of h of x. I'm tempted for that too, but I also have seen this sometimes be multiplied, which is weird. It should really they should write it out this way.
They do write that out when they mean that.
Right? So is this a composite function then?
Yeah.
Okay. All right. We're going to assume it's a
Which
composite
is what
function.
makes this a little bit annoying. And I'm happy it's not G of H.
Yeah.
Or
Okay.
G of F.
Right. Okay. So this doesn't mean multiply. This means you need to plug h of x in for x in f. So here's what we say. So I'm going to use some fancy colors here. So f of, and then let's use green, of x, right? Oh.
Of H of.
Yeah, and we'll get there. I'll show you. So this is 2, and then it's x squared minus 8. Okay. But now I want
of x.
f of h of x. So
H.
h of x. So instead of this being an x, I want to plug in h of x, which means this has to now become h of x. All right?
Which H of X is defined.
Good. Yeah, and h of x is defined as this. So this would become, so f of, or here, I'll just copy this. F of h of x would be equal to 2, and then it's going to be h of x squared minus 8. But then h of x is equal to 2x plus 4. So this equal to 2, and now it's 2x plus 4
Wait.
squared minus 8. Yeah. Fun fact, I'm actually looking at doing a bachelor degree in math. Oh, hell yeah, dude.
That's dope.
Do it, Isaac. Math degrees are cool. We got a bunch of friends here who have math degrees. I have a physics degree, but math is definitely a big part of what I do. Okay. So then to do this, Adarsh, right? Now you just have to like square this. So this is the same thing as 2. A couple ways to do this. I could just say that like 2x plus 4 squared is the same thing as 4x squared plus 16x plus 16. If you know how to like expand binomials. This is called the binomial expansion. Otherwise, you could FOIL it. You could do 2x plus 4 times 2x plus 4.
Or
But
would you realize is the same rule?
Yeah, you just got to do all this garbage. I don't like to do that stuff. It makes me sad.
You realize that it is that same thing.
Yeah, yeah.
And Isaac is something. Oh yeah, he's multiplied.
Good. Yes. So,
not-
I don't think it's 16x squared though. I don't think it's 16x
Yeah?
squared.
No, yeah, he's multiplied.
Well, so now, okay, so this now goes here, but then you have a 2 multiplying outside, right? So that's going to equal to 8x squared plus 32x.
He's correct. He's correct. He is one number off.
Yeah.
His 16
plus-
is the only error.
Yeah, there you go. You're good. You're good, Isaac. Good job.
Otherwise, he's correct.
And then minus 8, and then good. Yeah. So yeah, all we did here is then we multiplied the 2 inside. So all this. Right. All this was that. And then we got this. So then you can simplify a couple little things. You just simplify these two things. And so you get 8x squared plus 32x plus 24. If you want to be super, super cool, pull the 8 out. And now it's x squared plus 4x plus 3. Do you factor it? What does she want?
But it won't factor nicely anymore. That minus 8 is what made sure.
Oh, it actually does. No, it does, right? Because isn't this x plus 1, x plus 3? Right, Seth? Is that true?
Yeah.
Oh, okay.
Definitely did factor, which helps if you're trying to put something else in this.
Find each function? Yeah. I don't know. Like, if I was your teacher, I would accept this. I'd be like, cool, that's fine.
Reason?
Seth, which one would you only accept this one? Thanks for the follows,
I would not
guys.
accept either of those.
You wouldn't accept why? What's wrong?
Is there expressions?
Other expressions. Oh, okay. So Seth is so right. So I have to technically say this is F H like this. I have to say that.
Yep.
What's up, Cytos? Oh, what's up, Pen? Yo, Pen Center. How do I factor x to the 4th plus 4? Oh man, I don't know if that one works. I could do x to the 4th minus 4. You want me to do that? I could do x to the 4th minus 4. X to the 4th plus 4 doesn't really work. But
Well, it
x to
actually
the...
does factor. It does factor.
What does it factor to? I don't think it does.
And here's how I know they're factor because any given function must have different roots.
They're imaginary though, are they not?
Correct, but they're still factors.
Okay.
And so because of that, any given roots must be included in a factor.
Okay, so what is this? X
Therefore,
minus
for any given
2i,
function, there is
x
exactly
minus
that
2i, x plus 2i.
Any given function, there is exactly as many factors as the highest
Thanks,
power
Penn
of
Center. I
that
appreciate it. You have a great. Hey, I hope you're having a great day, Penn Center. Is this what it is? The factors are 2i, no? Or no, I have this wrong. Sorry. Square root of 2i, right?
You said no imaginaries, so yeah, you have to. It's a squared factor. It's 4 different factors.
But I can't have factors
There are 4
that
different
aren't
factors.
imaginary. That aren't imaginary? Oh, you want me to do like e to the pi I?
There is actually 4 factors. There are 4 different factors.
Can you like people? Yeah, to how to get help through our Discord? Yeah, totally, man. Yeah, so here's our Discord. If you want to go join, that's an easy way to. You can like submit questions here, in our channels, and that's where we go over them on the stream. We also give out like gift cards and stuff if you do good things in life. And then also, if you want to just like submit a screenshot using a web app, you can just go here to submit. And then if you want to figure out when anyone else is streaming, there's a calendar. And then they're all our friends. Because I hired them. I was told this is possible to factor into 2 irreducible quadratics without imaginaries. I don't think it is.
You may be accurate on it as 2. Imaginaries. Two imaginary
They-
factors will
They
become
have
a
to be
quadratic
imaginary, dude. What are you
transformation.
talking about, dude?
Become a quadratic.
X to the 4th plus 4? I'm-
It's your x to the 4th plus 4 when you type it.
Yeah. What does Wolfram say?
Okay, and it's in a
Yeah, this
plotted
never
form.
touches the x-axis, dog.
Have a look, though.
It has
There's alternate-
complex roots. Yes, I'm
Look at the
okay with
alternate
these.
form. Look at the alternate form, though. Read the alternate form for me.
Dude, oh, where the hell did this come from?
Did it Wetson? That is a fact. Those are two irreducible
Oh,
factors,
shit.
which
Wait,
means a
what?
tan factor.
Oh, wow. Well, no, but the factors of these are imaginary.
Well, no, we don't care about that. We just care about their irreducible quadratics.
Oh.
So
Well, how are you
that's
supposed to
why I
determine
think
that?
it can be.
You use the quadratic formula?
'Cause you can do that.
Okay. Okay. I'm curious about this quadratic formula thing. Wait, what? Is it quadratic? Are you saying that, like,
Quadratic times quadratic is a 4th power.
okay.
Therefore, this must have 2 quadratic factors, and then each quadratic factor must have 2 factors.
Are you saying this? Are you saying that, like, let b equal x squared, right? So b squared equals x to the 4th.
Mm-hmm.
So then this is b squared plus 4. And then this is like b squared. All polynomial. Oh, one sec. This is what, since Penn Center says all polynomials higher than x to the 3rd are factorable into irreducible quadratic and linear factors. That's cool. I didn't know that. Let's see how it works. So if I rewrite this way, and this is the only way you can use a quadratic formula, right? Is if it's quadratic. So you get x equals negative b, so that's 0, plus or minus the square root of b squared, again 0, and then minus 4 times 1 times 4.
Which causes a problem.
That's going to be
Means
imaginary.
you've done something wrong because it can't cause a problem.
I don't know what I've done.
I would tell you that if I was to solve that for its roots, b squared plus 4, I would.
Well, you would get plus or minus 4i. You get plus or minus 4i over 2. So you get plus or minus 2i. Okay.
B is in some of
So-
square roots, we get imaginaries.
Plus or minus 2i
It's part of imaginaries.
is equal to b, which equals x squared. But that's not nice. Because the imaginary roots come in conjugate pairs. Okay. I'm confused why this doesn't work, though.
We don't want that.
X squared
don't want
minus
imaginary.
2i times x squared plus 2i.
Your quadratics do not.
Oh. My quadratic's not. Sorry, what were you saying?
Nothing.
So Isaac says here from TikTok. So we have cross platform collaboration here, which I love.
Machine learning course.
Yeah, it says that you can write x squared minus 2i times x squared plus 2i. Okay, I think he's talking about this. Oh well, yeah. Okay.
That's the duh. That's what do this.
Yeah, that's
That's what
x
the
squared
roots
plus
are.
2i, x squared minus 2i.
Which are not helpful. That's not what we want.
B squared.
But
He says b squared. Cough, cough, cough. Wait, maybe I forgot something. Maybe I missed something. My bad. One sec. B squared plus 0b plus 4 x equals negative 0 plus or minus the square root of 0 squared minus 4 times 1 times 4 all over 2. This is what I had. I'm confused where I'm messing up here. So
Okay,
this is
so-
plus or minus negative 16 over 2. So that's
Okay.
plus or minus 4i, right?
divided by 2, which is
Is equals plus or minus 2i.
which
Okay.
place ats on there and change their sign system. So b plus 2i, b minus 2i. That's
Oh,
what
okay.
it's saying.
Wait. Okay.
And what's
wait.
b equal to?
No. Wait, I'm sorry. It's so my factors are right.
The
Isn't-
factors that we
isn't-
care about, yeah.
Isn't it b minus 2i B plus 2i, right?
Then what's B?
B was x squared. Yeah. Okay. And then what do I do from this?
We still need imaginaries out of this.
How do I get the imaginaries out of this thing, though?
What's the difference? What's the difference between those two? Between that and the answer that was given on?
Oh, it was given on Wolfram?
Yeah,
Oh,
subtle difference.
I see. I think I see
Subtle
it.
difference then.
Um.
I equal 2. What did they say I was equal to there? Because they factored a 2 out of that, didn't they?
Mm,
And 2i is a 2 times s plus 1.
yes.
What's s plus 1?
What is x plus 1? X plus 1 must be equal to I then, no? No, x minus 1 equals I.
What I'm getting at is these are imaginaries for a reason, which means this does not exist on the real plane.
Okay.
Which means at some point this is an imaginary plane. What if I put that there? This
I'm still not seeing it. How we get from this to this?
that's it for steps if you can, because it might have steps. I don't know.
No, I can't get it to show steps.
You can get ChatGPT to show steps though.
I could. Do I do the quadratic equation of this now? Is that what I do? Wait. Do I do the quadratic equation of this now?
Well.
I think I
the problem
could.
is you want to stop at quadratics. 2 irreducible quadratics is our goal.
Oh, you're right. I do. Yeah, I want to stop. I want to stop.
More is just roots,
Right.
but they're helpful. But that would be helpful because
Then I think I take the root from one of them and I put it with the root of the other one or something.
if they're squared roots, if they happen to be nicely the same,
Yeah, which I think they will be. I think if I quadratic formula this again. Yeah, I need some way to connect the dots. I'm sorry. So I had x to the fourth plus 4. I said let b equal x squared.
Okay, yeah.
B squared equals x to the fourth. I got this, which I then solved the quadratic formula to get these two roots, which then got me to this.
of b, these two roots in terms of b, of course.
Yeah, it is a complex question though. It's kind of fun. And then we need this to somehow turn into this. I'm tempted to quadratic this again, Pen. To say this is 0 plus or minus the square root, and then it's 0, and then it's plus, right? 4 times 2i all over 2. And then the only difference is that this one.
That's neat. That's neat.
So watch. So this
okay.
is what's neat.
They didn't even whatever machine did this one did not even bother to do quadratic. They says factor by grouping and then dealt with it.
They factor this by grouping.
The starting s to the fourth plus 4.
Yeah.
Factor by grouping is what they did. I don't.
How do they factor this by grouping? I only got 2 terms.
Add to the fourth plus 2x cubed plus 2x squared minus 2x cubed minus 4x squared.
Oh,
Minus
that's
4x plus
cheating. Yeah, but that's cheating.
What?
You're just doing like a massive completing the square.
Yep.
Yeah.
I guess so. That would work.
That's cheating. Wait, what's the square root of I?
Beep, 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 beep. There's your
Are you-
answer. There's raw DBA. There's a square root, but it gets more stuff.
Oh no. Okay, one sec. Let me help out Ethan. Sorry, this is a fun question, but let me help out Ethan. Ethan, where are you? I need to help out Ethan before I have to go
You need
teach.
to stay later.
Yeah.
you need
All right,
help
we're gonna save this for later. Ethan, where you
In
at?
the world did you get? How did you get into I?
Sorry,
Where was
yeah,
the
I
negative
went down a
one?
rabbit hole. I mean, it was a fun
It's
rabbit
simple.
hole, but let me make sure we help you
I mean,
out
hey,
before I gotta go. Okay.
The
Irma's
thing
take-home
is
pay
that
is for.
can't-
Yeah, what's up?
You can't dig out. Like the more you keep digging, the harder it is to get out. Like
It was.
quicksand,
Yeah,
you know?
I should have just thrown the grenade. Yes,
Yep.
Darsh, you can definitely get a bonk coin. My bad. Sorry.
Irma's take-home
alright.
pay is $4,320 per fortnight.
Per fortnight. Oh yeah, do you guys know what a fortnight is now?
It's defined
What's
there.
a fortnight? I know.
Each fortnight, Irma's pay is allocated according to the following table. What is Irma's annual take-home pay? Assuming 32 weeks a day,
Like-
52 weeks a year.
Okay, I know annual will mean year, but like, it's like I don't even know where to
Mhm.
start. That's
Okay?
just the only
Because it is.
question. But
I'm gonna ask you two simple questions. This will go easily.
Yeah.
Okay. What is the annual?
Okay.
What is the fortnight pay?
what? Oh well,
What is the
4,300.
What is her pay per fortnight? What is her pay per fortnight?
Oh, did I lose my stuff?
4,320.
Yeah.
4,320.
4,320. How many
Sorry.
fortnights in 52 weeks?
Yeah.
What? Before
How
this
mu-
fit into 2 weeks.
How many
what?
how many fortnights are in a year? Do you know that, Ethan?
How many How many twos are in 52?
Yeah.
26.
Good.
26.
So yeah, dude, what? Why is all my stuff disappearing?
You are erasing. You clicked on the image and erased it.
No, 1 second. I'm gonna just delete all this. Okay, there we go. Sorry, I don't know why it was doing that. Okay, there we go.
And
Okay.
multiply.
So 1 fortnight, or here's what we say. We say 26 fortnights. Oh, I don't know why
Say
that's
20
happening.
Something.
26 fortnights is equal to 1 year,
Just put FM.
right?
Yeah.
In one fortnight.
So if you want to know how much is paid, and 1 fortnight is equal to $4,320, right?
Yeah.
So how much does she get paid per year? So you can do this. You get how many dollars per year is equal to $4,320 in 1 fortnight, and then what you know is that 26 fortnights is equal to 1 year.
Cancellation is going to help
Yeah.
you if you switch something around, because right now you're wrong. Right now this is going to do nothing for you. $4 a year, switch that to euro per dollar, so it cancels. So yours will cancel for you.
No, I want to keep it as dollars per year. Dollars per year, and then I want dollars per year.
Dollars per year. Yep. I see
Yes,
euro.
okay.
It's equals. Yep.
Yeah. So, Ethan, you're going to take that 4,320 you had, right? And you're going to multiply it by 26.
Yeah.
Okay.
I wish there was a trick just to do it quickly.
Well, this is the trick. I mean, the trick is that, like, there's 26 fortnights in a year, and every fortnight she gets paid 4,320. So you do 4,320
I mean,
times
like-
26.
I mean, like multiplying numbers like in a whole. Like, I've
Oh, no.
seen many tricks in-
There's not a trick for this. This one sucks. You can't do that. You can't do it.
Nice, but they are nice. They are also nice.
Yeah, these are not nice numbers.
They're absolutely the trick. If you don't, I can show you another way this is written.
Well, here, 1 sec. Let me make sure I got this done. What is her annual? Oh, is this the only question, Ethan?
Yep.
Is just this? Is
That's
this
it.
part? Is that it?
Just wanted to know, yeah. Is
Oh,
that it?
okay. Yeah, that's it, dude.
Here's a way you can do
All right.
it if you want.
Seth, tell me the easier way. What's the easier way?
Okay. No, well, it's not an easier way, but it's a mathematical way of doing it without a calculator and yet not having to do all the formula.
Okay.
So
'Cause-
write the following: 4,320 times 26. So we have we're workable.
Okay.
I know that 26 is what?
2 times 13?
Give me some addition instead. Because I like divisibility.
20 plus 6.
I don't like 20. Try again.
10 plus 16?
13 plus 13?
25 plus 1. Just 25s I know.
He's going to say this is
And
equal to 25
I
plus
also know
1.
that 4,320 is divisible by 4.
Do you?
So-
Oh, I
Yeah,
guess,
like-
because
What?
4,000 is... Yeah. So 4,000 is obviously divisible by 4, and then 320
Divide
is
that-
divisible by 4.
Divide that by 4 for me. Because I'm going to
Yeah.
do...
Yeah, that's
I'm gonna pull- I'm
1080.
gonna pull one. I'm not going to say this is the same thing as 4,000. No, before you do that, I'm going to maneuver one thing.
Yeah.
4,320 times 25 plus 4,320.
Oh, okay. Sorry.
That is
I see what he's saying.
4,320 out of
I
the
see what he's saying.
This
So 1
is a
sec.
4,320
He's
mess.
distributing this into here, and he's distributing this into here. So he's saying 4,320.
I don't want to do it at the end.
That's okay.
We don't need
25.
that at the end. We can just-
And then he's going to say plus 4,320
And
times
now,
1.
we can use the rule that we say, we have done this before, and 12 times, we did 6 times 24. How did you do it? Well, we said that 24 is 2 times 12. 4,320 is 4 times what?
4 times 1080.
Okay, 1080 times 100.
108 times 100. Oh, no, I see what you're saying.
You see what I
Actually,
did?
there's a really cool trick he's doing here, Ethan.
80 times 25, and what's 25 times 4?
Right, and then he's grouping these together.
100.
So 4 times 25 is 100.
5 times 4, 100. So let's tack 2 zeros onto the 1080.
And then, yeah. So then this tacks on 2 zeros. So now you have 1080, 0, 0. Wow. Oh, this is really cool. And plus 4320. That just comes down from this.
A calculator.
And now you don't need a calculator.
That's
Because this is 1, 1, 2, 3, 2, 0. Wow.
Nice and simple.
That's the same answer. Wow, that's super cool. Dude, nice. That's actually a really cool trick, Seth.
That's not easy to be honest.
Congrats, Ethan. You got 300 bond coins, too. That's pretty dope. Okay. All right.
No,
I gotta. Oh fuck! I'm late. Sorry. It's
I
my
know.
clock here's wrong.
I have one little puzzle.
You gotta go. Never mind.
I'm able to get it.
Screw everything. You need to go. You need to go.
I do need to go. Sorry. I my clock here is 3 minutes later than my other clock, so I need to end the stream. All right. Cool. All right. Thanks everyone for coming office hours today. Appreciate all the questions and everything we went through. Again, if you want to catch us tomorrow, we'll be streaming an hour later, 5 p.m. Pacific, 6 p.m. Mountain, 7 p.m. Central, 8 p.m. Eastern. Come on by, ask your math and science homework questions. We'll go over them. Sorry, don't have much time for pleasantries. We're gonna go raid Dawn. Dawn is great. We love Dawn. Dawn's doing more math stuff. If you want to go ask some cool math questions from Dawn, go say hi to him. Otherwise, yes. Enjoy the rest of your Tuesday. Have a wonderful week. And again, thanks Seth as well for the help there. It was really cool.
Yep.
All right. Peace out, guys. And yeah, good to see you guys on TikTok and whatnot. We'll be back tomorrow.
That's dope.
Peace.